Okay, so sound and the ear. Coming back to physics of music. How are sound waves produced? We know sound waves are pressure waves that move forward. As a pressure is being formed, it moves away from the object. And we know the larger the amplitude, the noisier the environment. So what's the difference between this versus, I'll call this picture A and call this picture B. This one will hardly go anywhere, right? This noise that's produced in picture A, whereas this one will hit the next one, will hit the next one, that will hit the next one, will hit the next one, and sound will propagate further. So we can say small amplitude sounds, less energy, less transmission. So we'll write it like this. Small amplitude means low volume, means low energy, and less transmission. Large amplitude, large volume, high energy, more transmission, or further transmitted, right? More or further. That's why when you're in a big concert, how loud are the speakers? If you're really close to them, they have to be really loud in order to transmit further, especially if you're outdoors. They have to be really loud. Whereas when you're in a small room, even small amplitude sounds can get to you and you're fine, right? Okay, so sound energy, in fact, is very, very tiny. And here's a good way to think about it. So to appreciate how tiny the sound energy is, a 1 watt bulb is that like that night lamp that you have in your room. That 1 watt bulb divided over 1 trillion people. Okay, imagine, what's a trillion? A trillion is 1 million people that are spread over a square meter. What's a meter? So a meter is about yay big. Okay, can you make a box with a meter? So everybody put your arm out like this. So this is the closest the next person will be to you. Got it? And if you put 1 million people at arm's length, and then divide 1 watt, you know that tiny night lamp that you can hardly tell that's in your room when you're sleeping? Divide that energy over all of these people. That's how much the energy of sound is. That's how much we can. It doesn't mean that's how human hearing starts. Like that's the intensity you need for your eardrum to vibrate. And you know your eardrum only vibrates the length of a hydrogen atom at that rate, and you still hear it. Okay, let's wrap our minds around how big the number I'm talking about. So if you had $1 million, would you consider yourself to be a rich person? Okay, would you consider yourself to be well-to-do? Okay, now if you had $1 million, okay, so let's start with this, 100 million, would you be a rich person? If you had $1 billion, would you be a rich person? We are talking 1,000 billion. Wait, how much is Zuckerberg or what's his name, the Amazon guy worth? Bezos, how much is he worth? Can someone Google that? Billion, right? So I'm rounded up. So let's do 200 billion. We're talking 1,000 billion. 1,000 billion. and one tiny light bulb energy of 1 watt. That's how much our ears can hear. And our ears recognize 10 to the minus 10, 10 to the minus 15 meters of movement. That's what our brains can decipher. Like a really good one, right? Not everybody, but like that's what humans are capable of. I don't know. The first time I realized that, I was blown away. So we need 10 Zuckerbergs to about equal what we're talking about in terms of dollars. That's insanity, right? That's the sound energy we need in order to make a movement in our ear.